safety glasses. Next, both circuit breakers should be in an open position. This will allow current not to flow through it. Now connect the batteries. Now that the batteries are connected, we need to charge up the capacitors inside of each inverter. And I'm going to do that with a pre-charge resistor. And use the resistor to allow current to flow around the circuit breaker to charge up the capacitors. And after you wait for a few seconds, then you can close the circuit breaker. And that's it. Now we can safely turn on this inverter. Then repeat the process for the other inverter. Now both inverters are connected to a single battery bank. We need to add the cover to each one, and then we can turn them on. Oh, there we go. We have power. Keep in mind when the output says 120 volts, that means we have live connections in that panel, so be very careful when you turn these on. Now let's repeat the process for the second inverter.
This is the HP Envy X360 13-inch convertible, a 2-in-1 Intel Evo laptop engineered with powerful creative tools for wherever and whenever inspiration strikes.
Now we need to program these inverters so that they will communicate with
These skiers are all here because of trash. That's because underneath the slope is a huge garbage incineration plant. It processes 400,000 metric tons of waste a year and turns it into energy and heat for Copenhagen. It also recycles 90% of the city's metal waste. Some say such incineration plants could be key for solving our global trash problem. But is that true? Or are we just going to end up getting burned? Globally, we produce over 2 billion tons of household waste annually, with high-income countries generating an outsized amount compared to their populations. 37% of global waste ends up in landfills, polluting groundwater and producing methane. Less than 20% of the world's trash is recycled or composted. In the global south, many people have no access to trash collection, and it often ends up in rivers, a primary source of ocean plastic. To get rid of as much trash as possible, as fast as possible, around 1 billion tons of waste are openly burned every year.
Open burning generates high levels of black carbon, which is soot, which has a really strong global warming effect.
Zoe Lankovich is one of the founding members of Waste Aid and has been a waste manager for over 20 years.
It also generates dioxins and furans, which are known to cause cancer. All of this is going into the local air wherever people are burning waste.
Women are more directly impacted, as they are often responsible for disposing of household waste. Burning trash this way is a serious problem, but done differently, there are advantages to it. Here's where controlled burning, aka incineration, comes in. Incinerators first appeared where it was hard to landfill, in London in 1874, then in New York City in 1885.
The incineration process itself, it reduces the volume of the waste to 90%.
Ella Stengler is the managing director of the umbrella organization for European waste-to-energy operators.
And it fulfills a kind of sanitary task because it destroys the pollutants which are embedded in the waste,
The generated heat can also be turned into energy. It's called, unsurprisingly, waste to energy. In the US, where there's a lot of space and cheap energy in the form of oil, waste to energy wasn't so competitive and many plants were closed. But more and more plants were built in the EU. Today, they provide power to 18 million Europeans and heat to 15 million. They're a common waste management option for countries like Denmark and the Netherlands, which have almost completely eliminated landfilling. Environmental organizations see potential in waste to energy as a transition step toward a more circular economy, especially in countries without much space that need more energy. Here's how the plants work. The garbage is dumped into a big pit. From there, it's fed into the furnaces. They burn extremely hot, and the waste is reduced in a matter of minutes. The heat from the fires generates steam, which turns turbines to create electricity. The steam can also be used for heating. The 10% that doesn't burn is called bottom ash, and metals can be recovered from it. The rest can then be used as construction material. So the process reduces the volume of waste, creates energy, and part of the residue can even be recycled. What's not to love? Well, there are a few reasons why the world isn't full of waste-to-energy plants with ski slopes on top. One of those reasons is fly ash, which is everything caught by the filters. It needs to be disposed of in a hazardous waste facility. Another reason is cost.
If there would be a waste-to-energy plant built, it should be equipped with a state-of-the-art technology, and which is expensive, and you need to train the staff to properly operate it, and also authorities to monitor it.
Even without ski slopes, waste-to-energy plants can cost over $1 billion to build. Without the latest technology and monitoring, pollution can reach unsafe levels and impact people living nearby. And they also emit a lot of CO2. In the EU, around 52 million tons per year. That's like 430,000 cars, each driving 1 million kilometers.
Policymakers and industries put incineration in the same type of energy group as renewables like wind or solar or even nuclear.
This is Tatiana Lupan. She leads the plastics team for Client Earth and is also working to implement the EU's Circular Economy Directive.
But when you look at the greenhouse gas emissions of incineration, they're actually pretty close to coal and gas, and way far from wind, solar, nuclear.
A study commissioned by Client Earth found that controlled incineration generates between 59 and 73% of the emissions that coal would. Classifying this energy as renewable can divert funding from more sustainable waste management technologies like recycling. So, where it can be correctly built and managed, controlled incineration is better than a landfill, but it's by far not the cleanest option to handle waste, no matter how much energy is won. Have a look at this waste hierarchy here. Bear with me, it's less complicated than it looks. At the very bottom of the pyramid is open burning or dumping, the worst possible way to get rid of trash. Disposal without energy recovery is next, so landfilling or incineration without energy generation. Then here's where waste to energy, which is an umbrella term for a few different methods, comes in. Then comes recycling. Even better is to reuse things, often called upcycling, and at the top is prevention and reduction. Yeah, the whole world is pretty far from the top. That's why waste to energy is seen by some as a quick solution for countries struggling with their waste. Not surprisingly, plants are opening up around the world, like in China, Indonesia, and India. Africa's first waste-to-energy plant just opened in Addis Ababa, Ethiopia. But it has proven to be more complicated than just opening up plants and burning the problem away. One reason is that the composition of waste varies widely throughout the world.
You can't take one model that works in a wealthy country, like a cookie cutter, and expect it to work in a low-income country because it's a completely different different market.
In India, household waste is around 50% organic matter, like food scraps, which are too wet to burn. And because of the lack of centralized waste collection, trash there is often mixed together.
I don't think segregation is happening at all in majority of the Indian cities. So that's a major problem.
Pippa Randhawa has been conducting long-term studies on waste management in India for the past 10 years.
The waste has to be segregated and the undesirable material should be separated from that waste, and only the waste with high calorific value should be burned. But that is not something that is happening actually.
Calorific value is a measure of a substance's heating power. In other words, how easily it burns. Crude oil and mixed plastics come in at around 40 megajoules per kilogram. Food is about 16. Without waste separation, lots of food scraps find their way to the furnaces, forcing the plants to add additional fuel. This makes the whole facility extremely inefficient. Countries also need to have a place to store the hazardous waste. So if incineration isn't a silver bullet for the global south, what are other options?
You know,